we said this is an absolute value. It fails a horizontal line test. We restrict it. There's a positive side. There's a decreasing side. So we wanted only the increasing side, which was this guy right here. It had another piece over here, which we didn't want. So we restricted the domain. Find your minimum point, find your X cutoff, and restrict your domain. If you write this out, this makes life a lot easier to interchange your domain and your range. Because with this guy, this is a line. This is 1/4 X, here's your line, plus 3/2. And you have to restrict this domain. You have to say, only from 0 to infinity. You do not want that whole line. You need to be able to restrict that as well. The calculator does a nice job restricting it if you're looking at it. You know, if you want to see it in there, and then do your draw inverse first, and then do the little bubble thing over your inverse, and that helps you decide that you got the right inverse for that. Any questions on this one? You can absolutely leave me your equation like that. That's fine with me. To see that it is an equation of a line, sometimes it's a little easier to separate it. There's your mx plus b, your slope, your intercept. Okay? Stop me if you have any questions, because this is our focus today. Okay, here's a radical, and this radical automatically has a domain restriction. Automatically your domain is restricted. God bless you. So set that greater than or equal to 0 and find your restricted domain. That one we have no choice, we have to do that. The problem is, its inverse will be a quadratic. And we definitely have to restrict the quadratic part of it. So again, once you lay out your domain and your range, do the interchange. And this way you will get your domain. And you're going to have to restrict this domain. If you write them both out for me, that's fine. Or if you just write this, or sometimes people write it like this. You usually see it qualified, comma, x is greater than or equal to 0. That's why we saw those on the ones that we were doing in class. Just make sure your domain is restricted on your inverse, because your inverse will actually make you a parabola, and we don't want that part. Anybody have trouble with this at all? No? Here's your decreasing. It works the same way, except you're taking the other leg of it, the decreasing, from negative infinity to that turning point. So find your domain, and then your negative infinity, here's your original domain. This is the original. Your negative infinity, stop at -4, your range, 0 to infinity. It's a parabola. Restricted it to the decreasing part. So when you take the square root, remember you get a positive and negative. This time you want the negative. And that will restrict itself for you. Usually if the first one needs to be restricted, the inverse doesn't. If the first one doesn't need to be restricted, then the inverse does. Because you're squaring or square rooting. And you can still put your range and domain out there and have no problems. And you should be able to see, I'm not a visual person, so I always take this point and I interchange them. So now I know where my graph has to start. So it just kind of leads me to know where my graph goes. No questions? You guys were good. We're good? Good. Okay. And the last one Here's your decreasing part. And if you graph this in your calculator, you're going to see that even ones behave the same. This one happens to look like a quadratic. They behave the same way. Instead of taking the square root, you're taking the fourth root. And when you took the square root, you had a positive and negative because it's even. When you take the fourth root, you have a positive and negative because it's even. And just restrict your domain, find your turning point. Can all of you put that in your calc, or do you want me to put the calculator up here? We have the time, so I just want to make sure that you get these. Just look for your turning point. And work it the same way. Okay. I know some of you didn't do this one because the fourth root kind of threw you off a little bit. Alright, but I'm going to need help. What does this give me when I graph? Kyle, what does this give me when I graph it? In what quadrant? Second quadrant. So it would be 3 somewhere over here. Is it on the axis? So what's this minimum point here? Negative 3, 0. We want the increasing section. So we don't want this. We want this. We want our graph to look like this. So we want to restrict our domain from negative 3 to infinity. What's our range? 0 to infinity. Good. So we're going to take this guy and we're going to interchange the x and the y's. I'm going to reflect this and put it on this side. If you think of a simple, everything reverts back to a very simple form. Always write your simplest form down so you can see your process. Remember how we did this? We took the positive root, we took the negative root. So now you're about to take the positive root. I'm not working for some reason. Okay, I'm back working. Alright, so we're taking the positive root. So we're going to take this out and set this to positive x. If we were decreasing, we would set it to the negative x. So we want to solve for y. Subtract 9, divide by 3. Last step, replace this with your inverse notation. What kind of graph is this giving me, guys? A line. And a line is continuous. But we don't want it to be continuous. So we have to then take this domain and make this its range. We have to take its range and make this its domain. We want this restricted to this domain. Or if you do this, this is absolutely fine. Qualified. So you want a line, if this is your negative 3, 0, this is at your 0, negative 3. And it's going to go like this. We don't want the other part of it. And you can see your reflection over your line y equals x. Good? Same process for decreasing, except of course, my domain is the opposite. It would be from negative 3 to infinity. Okay? I'm sorry, negative infinity to negative 3. Everything would be reversed, and I would use the negative rather than the positive. Okay. Just write. Go ahead. I'll talk while you write. Out there is doing a decreasing one. You have to wait till you get your computer back for that one, huh?
Yeah.
Okay, so he interchanged the X and the Y. When he takes the square root, he gets a plus or minus. And he's using his negative because he's a decreasing. And he's solving for y. We work as a good team out here. Sorry, I didn't say that. Okay.
Yeah.
Good. Last step, take a y and make it be x. Good. There's his inverse notation. Good. Thank you. And your graph, do you have your graph by any chance?
Yeah.
You want to sketch it for us? Please. Thank you. Because we certainly know where that transformation is, don't we? To the right 2, up 2. Can you find your vertex that way? Probably even easier than doing on your calc, right? So he, sure. He restricted his domain. Yeah, once you make a mistake, you can't write over it. It's impossible. Especially when Rich moves my card. Okay, his domain is going from the decreasing from negative infinity to 2. And his range is from 2 to infinity. Good. So when he takes his inverse, good. Which luckily he didn't have to restrict because it was radical. Good, thank you. The only thing here is this line's going to come this way, a little rounded this way. That's your increasing part. You just want to do decreasing part, but it's perfect. It's perfect. Very good. Very good.